So, section 4-5. There's no vocabulary in this section. The main point right here in the essential understanding, many relationships can be represented by equations, and then you can use the equation to find the solution of a problem. Problem 1, writing a function rule. I wonder if such a thing exists. You can estimate the temperature by counting the number of chirps of the snowy tree cricket. I've never heard of such a thing. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. What's a function rule that represents this situation? So what they're doing here is they're kind of breaking this down, showing the steps. Temperature, 40 degrees, more than 1/4 the chirps. So then they picked variables, let t equal the temperature, let n equal the number of chirps, and then you turn it into math. T equals 40 plus 1/4, and remember of means times n. And then you have the function. So I think what they were trying to explain in problem 1 is just easier to understand when you try to do it yourself. So here's got it number 1. It sets up a landfill, accumulates a certain amount of waste every month, and you need to write a function that shows the total amount of waste after m months. You give it a try, see what you can do. I'll be here. All right. If only we had a number for the month's worth of garbage that we're trying to figure out. Well, why don't we use 5? No reason not to. So if we have 5 months worth of garbage, and then we just start adding in the numbers that they give us in the problem. Every month is 420 tons of waste, so 5 months times 420. And we already have 50,000 tons of waste, so we have to add that in. That equals our total waste. So you figure that. Setting it up this way is fairly straightforward, but now that you've gotten this far, it's pretty easy to just say, oh, here's our variable m, which would work for whatever number of months. We need to multiply that times 420, add 50,000, and that's going to be our total for waste. That's what you should have. So problem 2 adds a step. Instead of just writing a function rule, we are writing and evaluating a rule. Here is a plan of a concert arena. The reserved seating, the fancy expensive stuff, is sold out. And general seating is still available. They want you to write a function rule to figure out what possible maximum revenue you can get. And so they break it down, they give you a little diagram that I'd like you to look at. And then they define your variables, and then they start to put them together into a function. Revenue equals 10 times the number of general seating tickets sold plus 3,000. Where did they get the 3,000 from? 3,000 comes from here. Reserved seating revenue, $25 a ticket, 10 rows, 12 seats a row. That's how much money they've made from reserved seating. You have to add that to the cost of the general seating. And they figure out if every single seat gets sold, 480 of them, maximum possible revenue, 7,800. This is a very good example of dealing with something algebraically that you might think to solve arithmetic with just plain math, and then I would hand you your paper back and say, nope, I need to see it in algebra. There you go. Take a look at got it number 2. The kennel and the flea bath. Do some figuring on 2A. No writing, just thinking for 2B. You go ahead, give it a shot. So your process might look something like this. The cost for the kennel is going to equal the cost of the bath plus $15 times every day that the dog is there. And then I put in the numbers we know. Bath costs $12 and is going to be our variable for the days. And they asked how much it would cost for a dog to be there for 10 days. And the answer is $162. I think that's a pretty cheap kennel. That's nice. Letter B, you are, as I said, just thinking. They asked, remember, if the dog stayed for half the time, so if the dog stayed for 5 days, would that cut the cost in half? And I know that you all thought about that and you said, why, no, it wouldn't cut it exactly in half because we still have to add $12 to whatever we come up with. And if you don't believe me, then you can try it out. So top of page 264, and man, I thought the multiple choice problems made me a little crazy. I think the gridded response ones might make me crazier. Why? Well, because this only exists in standardized test land, and I don't want to teach you that stuff. I want to teach you math. All right, they're going to go through the process to write a function rule. You've seen a few problems like this in other places. A little review, always good. So, we've got a rectangle here. We know that the area is going to equal the length times the width. Now let's substitute in what we know. We know that the length is 5 feet more than the width. So that means we can show this side as W. We can show this side as W plus 5. So to figure out the area, we're going to multiply W times W plus 5. So here is the function that we end up with. Area equals W plus 5 times W, or once you distribute that W squared plus 5W. Then you substitute whatever number they give you and you're all good. Got it, number 3. You're going to do something similar for the area of a triangle, although I think this problem's much more of a pain than this problem was. Anyway, give it a try. And, you know, for letter B, I don't want you to graph it. I just want you to figure out how the rule is nonlinear. And I'm going to, you know, spend more time catching the light with my sparkly pencil. So we know that to figure out the area of a triangle, we need the base and the height. They tell us in the problem that in this triangle, the height is twice the base plus 4. So substitute in 2b plus 4 for height in your equation. And that will look like this. This says area of a triangle equals 1/2 base times height, which in this case is 1/2 base times, and this whole thing is the height, and we have to distribute it. And to try and keep this kind of clear, I did it this way. 1/2 b times 2b plus 1/2 b times 4. So we end up with b squared plus 2b. So now that we've got the formula that we need for this particular triangle, they want us to figure out what happens when the base is 16 inches. So then you substitute 16 into your function. 256 plus 32, you end up with an area of 288 square inches. And linear or nonlinear function. Anybody remember what I said in the other chapter about functions with exponents in them? Because if you do, that will give you your answer. Yep, skip the graph, linear and nonlinear, and finish up with the lesson check number 1 through 7 on page 264. All done.